Now we'll take a look at some examples where we can practice the theorems we just learned. Example number 1 says that we're given a diagram and we need to indicate which line segments are parallel. When I look at the first diagram, I see that we have a quadrilateral A, B, C, D, where the diagonals AC and BD have been drawn. Further to this, we see that diagonals intersect at a common point, which I will call point E. And according to the diagram, the side BE or segment BE equals ED and segment AE equals EC. So that means that these two diagonals bisect each other. Diagonals bisect each other in parallelograms, which means that A, B, C, D must be a parallelogram. So therefore, we'll say that the side AB is parallel to side BC. So we'll write AD parallel to BC. And also, the side AB is parallel to side DC. So AB parallel to DC. In the next example, we see a quadrilateral ABCD. In this quadrilateral, we see that the point Z is dividing AD into two equal parts. So Z is the midpoint of AD. Y is the midpoint of DC. X is the midpoint of BC, and W is the midpoint of AB. And all those midpoints are connected to each other consecutively. So that tells us, according to the first theorem, that WXYZ must be a parallelogram. So therefore, we'll say that ZY and WX must be parallel. And also, WZ and YX must be parallel. In the next example, we're given the diagram and we need to determine the indicated angles. So first, I take a look at the shapes. So the shapes we see here are the quadrilateral EFGH. And then we have connected the points T, Q, R, and S, which are the midpoints of each side of this quadrilateral. So as a result, a parallelogram has been formed, RQTS. And we know one of the angles, angle R, in the parallelogram is 115 degrees, 15 degrees. So that will make angle T equal to 115 degrees as well, because it is opposite to angle R in the parallelogram. So with T 115 degrees and R 115 degrees, there are 360 minus 115 minus 115 left for Q and S. So we'll write Q plus S equals 360 minus 115 minus 115, which is minus 230. And that will leave Q plus S equal to 130 degrees. Now angles Q and S are equal to each other because they are opposite angles in a parallelogram. So therefore each of them would be equal to 130 divided by 2, or even better, we will write that angles Q and S each equal 65 degrees. In the next diagram, we have A, B, C, D, quadrilateral. We have Z, Y, X, and W, the midpoints of the quadrilateral. So, which means that Z, W, X, Y must be a parallelogram. So, since angle W is given 53 degrees, then we'll say that angle Y, which is opposite to W, must also be 53 degrees. So we'll say that Y equals W equals 53 degrees. They're opposite angles in a parallelogram. Then we're going to say that angles Z and X are equal to, together, will make 360 minus 53 minus 53. So that's 360 minus 106. So 206 minus 6, then 260 minus 6, it's 254 degrees. So we're going to say that Z equals X equals 254 divided by 2. So Z and X equal each other 127 degrees. Okay, in the next question, we're asked to calculate the length of each line segment given that RU is 3.6 centimeters and RT is 6 centimeters. So we are given STYV, that's a parallelogram, and I know this because I am told that these sides are parallel, they have the arrows, and RU equals 3.6. It's better, especially when you solve geometry questions, to put all the numbers on the diagram, on the picture. So RU is 3.6 and RT is 6 centimeters. And we need to state the lengths of SR. So SR is right here, equals RU. So we'll write that down. And SR equals 3.6 centimeters. Next, we have to find SU. So SU is the total length of the diagonal. So that would be SR plus RU. That's one way of finding it. So that's 3.6 plus 3.6. And we'll say that SU equals 7.2 centimeters. Next, VR. Now, VR. What we are given is RT, which is 6. And VR and RT are equal to each other because they are diagonals of a parallelogram. And the diagonals of a parallelogram always bisect. So we'll say that is 6 centimeters as well. And then the length of VT, which will be VR plus RT, or 6 plus 6. That makes VT equal to 12 centimeters. Okay, moving on to the next example. We have to find the length of each line segment, if we are given that AC is 13.2 and XD is 6.6 centimeters, meters in this case. So what do we see in this diagram? We see that we have a quadrilateral ABCD, and we see that they have two sets of parallel sides. So that makes this quadrilateral a parallelogram. What we need to find in here is, or are, I must say, the lengths AX and XC, and then BX and BD. So first, let's put on the diagram the measurements given. So we know AC equals 13.2. And we know that XD, so only this side here, 6.6. So we'll say that AX, since we are in a parallelogram, the diagonals will intersect each other at a point, and this point will divide the two diagonals into two equal lengths. Therefore, we're going to say that AX equals half of AC, or it will equal XC, but we don't have XC. So let's say 1/2 of AC. So half of 13.2, and that would equal 6.6 meters. That would be AX. For side XC, or for length XC, we'll say that since we are in a parallelogram again, these two sides are equal, so it will equal AX. So XC equals AX. And we just found AX in here, so we'll say that XC equals 6.6 meters as well. The next line segment that we need to find is BX. So BX would be equal to XD. So BX must be 6.6 meters. And BD would be double of 6.6 because it's a whole diagonal. (13.2 centimeters). So when you think about it, we have some quite interesting finding here, and we have this 6.6, 6.6, 6.6 again, and BD is 13.2 right here. Okay, so that's not that easy. I'm going to give up, I guess. Alrighty down here. Okay, so it seems that the diagonals in this parallelogram are equal to each other. When does that happen? Well, it happens when you have a rectangle.